I'll talk a little bit about inventors. Talk about why we are here, why we are hosting this call. Just like give a background for those that don't know inventors. If this is your first time hearing about inventors, I know. So, inventors is a community of developers, designers, and all tech practitioners. So we have a sole aim of building and incubating innovative ideas. So to achieve this vision, the community has engaged in a lot of activities, such as frequent classes, teaching tech enthusiasts everything they need to know about tech, whatever field they want to join, be it web development, data science, cybersecurity, product design, and whatever networking, whatever you are interested in. Then we host a lot of webinars. An example is this one that we are doing right now, and we have hackathons that we host from time to time. So we have this beautiful SDG program that we host every year. So where couple of guys come together, form a team, and you get to pick part of the 17 SDG goals, and you build a solution around it. So with prices, attached to it and all, and so many other things that we do. So Inventors was founded by a group of visionaries. So I will be mentioning some of them. I won't be able to mention everyone. So apologies if I don't call your name. Just get the ball rolling. So the visionaries behind inventors include we have Adebayo Anthony. We all call him Tony K. So he's one of the founders of this great community. We also have Aderibole Juwon. We call him Jubos. He's one of our guys here. So he's one of the founders of this community too. We also have Ashek Okpelumi. We call him Willie Bells. So he's also one of the founders of this community. We have Frederick, we have Omo, and so many other big names in the industry that are part of the founders of this great community. So without wasting much of our time, like I said, today is packed, right? And there are a lot of things to learn. So this call is not only for maybe you're a data engineering enthusiast, maybe you're a data practitioner, wherever. But this call is like a general thing for everyone because there are some part of software engineering that you will hear during this call. So if you're a software engineer, you're a web developer, you should definitely stick around to the end because you will definitely pick something, right? So the speakers for today, um, we have Adebayo Anthony, who is the founder and the community lead of Inventors. Then we also have Akinro Timi Dominion. So Akinro Timi Dominion, she's the current lead of Inventors in OAU Tech. So one of our schools that we're active in currently. Then we also have Mist, our guest speaker. Her name is Chisom Oku. So she's a software engineer at Microsoft. She's an author and she's a content creator. So Chisom, can you just say hi?
Hi everyone, good evening.
Hi Chisom, nice to have you. All right. So then finally, you have me. My name is Shitolumide. I will be your host for tonight. So yeah, so that's that about that. So the next thing to do right now is to have like the brief introduction to data engineering. So I'll be passing the mic down to Dominion to do that. So Dominion, over to you.
All right. Good evening, everybody. My name is Akinrotimi Dominion, and briefly, I will just be introducing us to the concept and significance of data engineering. All right. I want to share my screen. Sorry for the delay. All right. Please, can you see my screen?
Yeah, we can. Yeah, we can.
All
But if
right.
you can pinch in a little bit bigger so that we can see more clearly.
Oh, okay. Sorry.
All right. Cool.
Yeah.
This looks okay.
Mm.
What's happening? Hello, Dominion.
Hello, can you hear me?
Yeah, we can hear you. Yes, we can hear you.
Ah,
All right, please go ahead, please.
all right. Okay. My PC is kind of low. All right. So briefly, I'll be talking on understanding data engineering, an introduction to data engineering. So simply put, data engineering is the collection, the transformation, and the storage of data. Simply put, which and this involves gathering data. Please, can anybody hear me? I don't.
Yeah, we can hear you. Please go ahead.
All right. Okay. And this involves the gathering of data, the conversion of data, and retaining data to enable, data analysis and enhance decision making for the particular organization. And data engineering plays a very, very, very crucial role in creating structured data pipelines and ensuring data quality. Now, what is data pipeline? Data pipeline, I mentioned data pipeline. What is data pipeline? Data pipeline is, let me just give um, the, let me just give a scenario of, a pipe that takes water from, let's say, your GP, your tank, to various locations in your house, like the kitchen, the bedroom, for various uses. So that is the whole concept of pipelines. So in short, data pipeline is just a method of moving and ingesting raw data from a source to a destination for storage and analysis. Now, what are the key responsibilities of a data engineer? The key responsibilities of a data engineer. First, they are responsible for designing data pipelines. As I said earlier, I explained data pipelines area. They are responsible for designing scalable data pipelines. When I mean scalable, that means these pipelines can undo a lot of data without slowing down or breaking. Number two, they are responsible for optimizing data flow and architecture. They're responsible for optimizing data flow and architecture. Number three, data engineers are responsible for integrating data from various sources. They're responsible for collecting data from, like different sources and putting them together in a way that makes sense for analysis. The fundamental skills for data engineering, the skills you need to have as a data engineer, like what are the skills that data engineers possess? Number one, you must be proficient in programming languages like Python, SQL, and Java. And SQL is kind of very important for querying and manipulating databases, which is one of the roles of a data engineer. Two, you must have an understanding of data warehousing and ETL processes. You must have proficient knowledge of data warehousing and ETL processes. And to those that these terms might be sounding strange, so let me just try to break it down. So data warehouse is just, let me say, a database, a specialized database that has been optimized for analytical queries and reporting, something like a data storehouse. And ETL means extract, transform, and load. You are extracting data from a particular source, you are transforming it and loading it to the data warehouse. So you must be proficient. You must have proficient knowledge on that. You must have solid understanding of distributed systems, because you'll be taking data from various sources and taking them to various sources too. So you must have a solid understanding on the idea of distributed systems so that you'll be able to design and implement efficient data storage, retrieval, and all. And last but not the least, you must have a mastery of cloud platforms, like Azure, Microsoft Azure, AWS. You must have a mastery on these because these platforms will be used to store and process. They are what most organizations use to store and process large volumes of data. And as a data engineer working on these platforms, you need to have an understanding of these platforms. Now, I'm just going to discuss a very important concept. Your data, it helps the organization store data efficiently, efficient data organization, and it is the foundation for database design. Sorry, can we access the slide now?
Please, if you can access the slide, please drop your reaction, please.
I mean, these are sharing, so you might not have to access the slide. You just
All right. Well, I'm on slide 5. All right. So okay. So those are the importance of data modeling and data engineering applications. Where can data engineering be applied to? How do they come in? What do they do? So data engineering helps. I'm just going to list a few. They help like if I say Ghana actionable insights for your organization. They enable organizations to derive actionable insights from complex data sets. They enable, data analysts to do their work and bring about actionable insights for your data. And data engineers, they power recommendation systems in e-commerce and predictive analytics in healthcare. So, career opportunities in data engineering. If you are studying data engineering, what can you do? You have the question of what can you do? Where can you apply data engineering? So, we have diverse career opportunities in data engineering, such as data engineer, yes, a data engineer, ETL developer, big data engineer, and data architect. And data engineering is in high demand. And if you are looking at um growing your career, you want to grow in your career, data engineering is the right option for you. So this is like the end of the slide, the end of the whole presentation. The future of data engineering. um Presently, we have a rising demand for skilled data engineers, and someone mentioned something that when you are learning data engineering, yes, when you are learning data engineering, you need not focus too much on the tools. You need to have basic understanding on the concept of data engineering because the tools change periodically. They change every time, every year. So you need to have knowledge on it. And um, when you have knowledge on the concept of data engineering and what you are doing, you'll be able to adapt to evolving data challenges. And if you are looking at you are new to tech here and you want to start a career in tech, data engineering is a good choice, yes, because I've not heard of any AI that is stealing the work of data engineers, unlike software engineers. The AI they just made now, Devin AI. So if you are looking at starting a career in tech, I would advise you to go for data engineering, although it's your choice. But that's all from my end. Thank you very much.
All right, thank you so much, Dominion. Thank you for
Yes.
that um, gentle approach and introduction to data engineering. So, hope we're all having a nice time. And my sincere apologies about the whole slide thing, but hope we're able to like follow with the whole presentation via the link. So, if you are raising your hands, please we will get back at you. All right. So, because I can see hands that are being raised right now, so we get back at you. So don't worry about that. So, but for now, please, Dominion, you can stop sharing your screen. So, so we can like enter the Q&A session with Chisom. I'm sure she's ready for us right now. So, in the meantime, I would like Chisom to like introduce herself. Tell us about herself, what she does, and I know most of us we all know her, but we have a tech queen among us, so let her do the honors of introducing herself. Hi, Chisom.
Okay, hi everyone, good evening. Thank you, Dominion, for that lovely presentation. So my name is Chisom. I currently work as a software engineer at Microsoft, specifically on the Windows engineering team. So my work is around big data engineering, building sustainable systems, and artificial intelligence as well. So, aside from engineering, I am also an author. I have a book that's currently helping people land jobs at international tech companies or fan companies in general. I think someone has created.
All right, thank you about that. Sorry, but Amosi, please kindly mute yourself. You are distracting us. Oh, can an admin mute him? Yeah. All right, thank you very much.
Nice, nice, thank you.
All right.
Well,
So,
yeah,
we'll be going to the Q&A session right now. So, this is how the structure is going to be. I'll be asking the question, like, I'll ask the question, then you just like answer it, elaborate on it, and if there are other questions, so I'll be looking at the chat. So if there are other questions, so I will pick them from the chat, then I will ask you. Sounds good?
yes, yes, it does.
All right, awesome. So the first question here. So the first one is data engineering is quite an interesting field. Now, who is a data engineer and what can you give us an overview of a typical data engineering process?
Okay, yeah, I think the Dominion touched on a couple of important aspects.
You did,
Okay.
yeah. She talked about who a data engineer is.
Yeah, so someone you were muted, so the noise was echoing. So she touched on some really important aspects, and defining data engineering is relative to the company you're working at and the kind of work that you do. But generally, the roles and responsibilities of a data engineer is actually very similar. So what you're basically doing, you're trying to make data available for the right people, either in-house or stakeholders that are outside of your company. So your work is majorly involved in getting data from different sources. Now, from these different sources, I mean APIs, websites, even like hard copy documents and multiple sources that you can think of. And you're just trying to consolidate that data into one place where people in your organization, talking about the business analysts, data scientists, machine learning engineers, data analysts as well, the managers, people upstream and downstream can easily access this data. Now, it doesn't just end there. You're going to be creating systems that manage this data. In terms of systems, I'm talking about data pipelines that would make sure this data is always available. Most of this data might be powering like a business intelligence solution, or might be powering a dashboard, or just something very important for decision making. So you want to make sure that data is always available. And inside that process, you also want to make sure that the kind of data that you're churning out is of good quality and it has like a very high like data integrity. So other things that you take note of as a data engineer would be compliance, making sure that all the data that you're accessing is compliant. We have several regulatory bodies that make sure of that. So security as well, and just everything generally around managing your data um, to be high quality and to be always available. So it's a lot, but those are like the few pillars that are quite important.
Awesome. Thank you for that detailed response. Thank you very much. So, the next question I have here is, what's the first step in selecting a tool to use for a specific process? I know there are so many tools out there. So, but what's okay? Taking you as an example, like let's use as a case study right now. So, what's like your own first step when you're trying to select a tool for a specific purpose right now?
Yeah, so I think data engineering, software engineering, DevOps, before you even think of choosing what to use, the requirements are still similar across these different fields. So the first thing you think of is the requirements that you have on ground. Now, for data engineering in particular, you're going to be looking at the data that you have. You're going to be looking at the volume of your data. Is this data big? Um, does this data come in different varieties, right? There's big data. We have something called the three V's of big data: volume, velocity, variety, and I can't remember the last one, but you want to ask yourself if you're dealing with big data or like a small size data. Now, for most companies, you also need to acknowledge the kind of company that you're working in. If you're working in a very huge company, you most likely be dealing with big data that comes in different types. But if you're working like a small startup or a small e-commerce store, you know that um, you're going to be working with data that is not so large. So this would help you. Second thing is, how do you want your data to be processed? Do you want your data to be coming in real time, or do you want your data to be coming in batches? So understanding the type of data that you want and you want to see it for real-time data is most likely things around like the finance side, or for batch processing, it might be you're working in an e-commerce store and you want to get like the amount of sales that you've had in that store bi-weekly or per month. So that's batch data. But for real time, this is data that's coming in milliseconds, like IoT data or IoT from IoT devices, for instance. Then what are the end goals? Are you just using it to report, or are you using it to do real time analysis? Are you using it for machine learning work, or you just need to understand what the end goals of your data. So once you finish defining like the requirements that you need, the next thing is to look at the things that are already within your organization, the things that are currently in use, the kind of cloud provider your organization is using, for instance, if you're actually using a cloud provider. Just basically assessing what already exists and looking at the trade-offs between using that or using something that you're just going to, or starting to use some like a new tool from somewhere else. Then you also want to understand how much your data is going to grow, how much tables you're going to be able to create. Now I'm talking about scalability, because you want to make sure that the tool that you're choosing can scale as the need arises. So you don't want to pick something that will be so limited in such a way that you won't be able to scale when you need to. It might happen in the next 2, 3, 5 years. So you need to think like futuristically. Then other things will just basically be cost, understanding that you're running a business or you're working for a business and you can't just throw money around. So you have to understand the cost considerations and how you can even help your company save money. Yeah, I think those are the few things I have in mind.
All right. Thank you. Thank you very much. All right, thank you so much for that. Sorry. Thank you so much for that answer. So please just like motivate and give the whole, I don't want the whole energy to be dull. So you can be sending your reactions so that your place looks busy, all right? So I want to talk about, although you are kind of like talking about it already, I wanted to ask you like how do you assess the trade-off between open source and commercial data engineering? So do you want to like talking about it? Or
Eh, Sorry, something just happened to your audio. I don't know if it's just me, but there's a change. Probably because
Yeah,
maybe more
for him
something.
too.
Hello.
Try again. Let's hear.
Okay.
Yeah.
So, right. I wanted to. Oh Jesus, can you hear me?
Yes, we can hear
Okay.
you now. That's better. Yeah.
Thank you very much. So, like I said, the next question I wanted to ask, you have already like started answering it. So, but I just want us to like probably elaborate on it, which is how do you assess the trade-offs between open source and commercial data engineering tools? Open source definitely is free and it's there for everyone to like actually like look and use. So, but how do you assess the trade-off between these two? Either to go for the open source tool or to go for the commercial data engineering tools out there?
Okay, yeah, that's a good question. Yeah, like you mentioned, open source is free, but at the same time, there might be some hidden costs that you might not really know about when you're adopting that tool. But in terms of cost wise, open sources will most likely help you cut cost, and which is better, I mean, for everybody. Then in terms of maintenance or like support that you get for that open source tool, because there's one thing in picking up a new tool, there's another thing in actually knowing how to use that tool and knowing where to run to when like problem arises. So in terms of maintenance, open source would be, I would say, better, because most of these commercial tools also have like things like documentations and customer support that you can call. But open source is most likely better because you have like a community of people and support services as well that could help you like answer questions that you need to know. Then another thing we could talk about would be security. Open source technologies usually have a lot of people are just always attentive when it comes to vulnerabilities. So these vulnerabilities are usually identified on time and they're fixed on time. But with commercial products, you have to either wait for maybe probably the next update to come up, or you have to submit a ticket for them to fix this, and this might usually take time. So I won't really say one is better than the other, but it just basically depends on what you can do at that particular time and the requirements that you have on ground, like I mentioned earlier.
All right, thank you. Thank you so much for that. So, I have a question. Now, where does cloud fit into all this whole process?
Okay, data engineering on the cloud. Basically, when I hear the cloud, I think of scalability, the ability to scale resources and using like a pay as you go model, right? So the cloud is, as much as it's scalable, is also cost friendly, because when you're putting out solutions, like I mentioned, one of the requirements of picking tools is the fact that you need to know how it's going to scale futuristically. And if it's not something you know at that moment, the cloud is something that can help you, because you only pay for what you need at the moment. And when you want to like expand, or when you want to scale, you can up your resources and pay more. So the cloud is very scalable. At the same time, it's very, very, very flexible. You have a lot of options. You have compute resources, you have storage resources, you have governance resources, depending on the cloud model that you're using. So you have a lot of options in terms of like the amount of resources that you have on ground. But the most important thing is the cloud will definitely help you when it comes to data storage and data management as well, because most of the time you need to have a place where you can store data that you're not using. You'll do your data warehouse activities, store data like data marts for other organizations. So the cloud provides you with those kind of options that you can use to better manage your data. So few words: scalability, flexibility, data storage and management, and also the cloud is very cost effective.
All right, thank you so much. Thank you for that. Moving on now. Data is very important because we all like interact with data every day of our life. Whatever industry you find yourself, we are all interacting with data. So, and there's this thing going around with an emphasis on data quality. All right. So I'm curious to know, what features do you look for in data engineering tools to ensure your data integrity and consistency throughout the pipeline?
Okay. Yeah, like I mentioned earlier, data quality is something that's very important, especially when you're working as a data engineer, because the data that you're churning out, the raw data that you're churning out from systems, as much as they come in form of, they just come in their raw form, right? Your job is to clean that data and make sure it's just make sure that the quality is okay, basically. So there are a couple of tools, and most of the cloud providers or most of these data integration tools already have them. I'll take for instance mapping. For instance, I'll be using Azure Data Factory. Azure Data Factory is an orchestration tool that you use for data migrations, data integrations, automating pipelines, and all of that. So on Azure Data Factory, you can easily manage your schema. By schema, I mean the field type of your data and the name of your columns and all of that. So you can easily manage your schema through what we call mapping. Before data is brought in from a source to another source, you have the liberty to make sure that data is properly mapped in terms of like data types, null values, having duplicates. Those things are very, very important. So I think Azure Data Factory is one of those tools. I can't speak for other tools. I can speak for ADF and Airflow, but I can't speak for other data integration tools that are available. But I think the most important thing is having features for these tools is having features that will enable you map your data properly and also handle different kinds of errors that might pop up, like version control, because version control is also very important. Because when something changes, you want to make sure that that change is replicated in all the systems that you're handling. So it's a whole lot. So most likely schema management, version control, setting up available monitoring tools that will trigger or that will just send you a mail to say, okay, this data is coming in, but this is not working, this doesn't look right. And you can just go back to fix up your pipeline. So those are the features I feel data integration tools should have.
Awesome. Thank you so much for that. We appreciate the explanation. All right, so just a quick one. So if you have questions, please use the chat section. Please just drop your question in the chat section. Nothing else, just your question, right? So that we can ask the question and the question can be answered, because this meeting ends in 15 minutes. All right. So we have to wrap things up immediately. So if you have questions, you can go ahead and drop it right now. So, but I have one final question to ask. So could you give a brief overview on data governance and the tools organizations can adopt to manage the movement of their data?
Okay, yeah. Sorry, I had a call coming. So data governance is something that I mentioned when we were just starting out with the call. One of your roles as a data engineer is going to make sure that your data is properly, in terms of like regulations, your data is okay. So data governance tools, like I could speak for Microsoft Purview, has like inbuilt tools that help you do these things. So in terms of data governance, what you're going to be looking at is data discovery, for instance. We want a place where people from different departments in an organization can go to and see the exact kind of data. So what do I mean? Someone from finance wants to check for something in your data mart or like your data inventory, and she sees a certain kind of data. Now, someone from marketing the goal is for someone for marketing shouldn't go there and see something different. So you want to create like a general place where people can go and see data and they are similar. You don't want data that's different. You don't want a database that carries finance data for one day and the second database that carries the same day having different values. No, you don't want that. Then second thing is like data quality. All these things are under data governance as well, making sure that you're doing the right transformations, you're validating your date time fields and all of that. Then managing metadata. People want to go there. I don't want people to go to my data inventory and be sending me the names of the database to ask for maybe what is this database about, what does this database do. So by metadata, I mean data that explains data that explains data that already exists. So I think the next important thing under data governance would be data privacy and compliance tools, making sure that your organization is very compliant with the GDPR, CCPA, regulatory bodies handling private data and personal data from people. So, top of my head, those are the things that you most likely be covering under data governance.
All right. Thank you so much for answering that question. So I can hear you coughing. So I will just like let you like take a cup of water right now. So I can ask someone else this next question in the chat. So you can grab a cup of water right
I'm actually
now.
good. I'm actually good.
Okay, no problem. So
Thank you.
nonetheless, I'm still going to ask someone else so that we can hear like a separate voice. So this question is going to Tony K. So Tony K is a software engineer, and I'm sure we have an idea about this. So Tony K, how do software engineers work with data engineers?
Yeah, I also wanted to mention that in some companies, these roles might actually, how do I call it now? These roles might actually overlap. Yeah, so if you're lucky, you get to do the software engineering and you get to get someone else to do data engineering work. But if you're like me, I don't think I want to call myself unlucky, but if you're lucky as me, you do the both, right? So what do I mean? You ship your features and you still do data engineering work to track those features and to get data to enable those features. So sometimes they overlap. Some companies you might have software engineers that do specialized software engineering work and data engineers that do data engineering work. But in some other companies, you can have software engineers that do both the software and the data side. So that's another part I wanted to mention. Exactly. Exactly. Yes, exactly.
All right, thank you very much. Thank you, Tony K. Thank you, Chisom. So this next question is directly towards Chisom. So Christopher said, in security, we have the CIA triad and its policies. But then I wanted to ask, how do security professionals protect sensitive data while maintaining its use for analysis?
Okay, he's asking if how do data engineers protect the data that they use? Is that the question?
Yeah, security guys, like for guys in cybersecurity, and how do you protect your sensitive data?
Okay, I don't think I can speak. I'm not a cybersecurity engineer, but on the data side, we have like data security policies. Top of my head, I think would be data encryption, making sure that you're encrypting your PPIs, that's your personally identifiable information, making sure that you're encrypting those personal information, making sure that your data is also compliant, like with the regulatory bodies. Then other things would be access control, the role-based access control, multi-factor authentication, to make sure that the people that are meant to access this data are actually just defining access like admin, editor, viewer, like you have on like your normal document and all of that. So defining access and encrypting your data. So that's the limit I can go to for data security because I don't currently work as a cyber security person.
All right, so Christopher, please, is that answer okay? Like, are you okay with the answer?
Yeah, I think. Yeah, I'm okay. I'm okay.
All right, cool. Thank you, Tony K. Thank you for adding that. So, Chris, I'm going to be asking someone else's question before yours. So, just hold on a little bit. So, I have a question from Omar. He said, as a follow up to your answer about the dynamic data maps for different departments, how do you simplify dashboard for non technical uplines for business intelligence?
Okay, how do you simplify dashboards for non-technical uplines? So I think it just basically depends because as a data engineer, you're not just working for yourself, you're working for like your stakeholders and you're working with the business use case that you have at hand. So yeah, like you mentioned, data marts would have um data different departments in the organization would have their own data marts depending on how like the whole system is designed. But for non-technical uplines or non-technical like stakeholders, you'd want to understand their requirements, their business requirements, what they need to see. You don't want to be showing them what they don't need to see or what they didn't ask for. So if they're basically asking for monthly sales or monthly revenue generated or like the top highest product in a particular branch, or that's exactly what you're going to be showing them. So as much as possible, even if you're not working as a data engineer, so far you're in the technology industry, you'd want to understand the needs of your users, so you don't end up creating something that's overly complicated, right? So I don't think you would have like two dashboards for technical, non-technical, but depending on like the requirements of these two categories of individuals, you want to make sure that you're delivering data, or you're representing data in the most simple format. So I don't know if that answers your question.
Okay, so okay, you have a thumbs up already. I think that answers your question. So for FYI, so he's one of our guys here too. So he's one of the co-founders of Inventors. So thank you so much, Momo. So I'll go back to the chat to pick another question. I'm sorry, Chris, I'm still going to jump your question. So Joshua said, are there some levels of automation the tool provided for common data engineering tasks? And is there a correlation of various data engineering tools with? I think, okay, these are two questions. So he's asking two questions. So the first one is, are there some levels of automation the tool provided for common data engineering tasks? And the second one is there a correlation of various data engineering tools with other data formats?
Okay, let me see how I can answer that. Let me see the first question. Are there some levels of automation?
All right, thank you very much. Thank you. All right, so I'll go over to the next question that we have here. So, Chris, I'm coming back to you right now. So, I think this your question has already been answered, talking about insider threats and all. So, the last question here is Christopher again. He said, in case of potential security threat within a large data set, how is data engineering used to detect this within the data set?
Okay, so this is where cloud providers come in. Usually, if you have data existing on the cloud platform, you would most likely have resources or features that could help you track things that might be threatening the information on your cloud or the resources on your cloud. So I talked about the role-based access control, which is one. I talked about data encryption as well, which is two. And the cloud just generally has features that would make sure that every step of the way, whether you're integrating data, whether you're sharing data with like another organization, whether you're creating data warehouse, moving pipelines, they have features that are available that would combat that risk or threat to your data workflow. So I don't know if that answers your question.
Awesome. Thank you. Thank you very much. So, guys, if you are enjoying this session, please, I want to see your reactions. Like, I want to see reactions. I want to see reactions everywhere. If you are really enjoying this session, all our speakers, they have been answering your questions. They've been doing well. So, the least you can do is like drop a reaction. Please, if you are enjoying this session, please drop a reaction. Thank you very much. And also, try to like check the chat. Our social media manager left some links there. You should do well to give us a follow, and just check out our profile, follow us, and be a part of our community. So the next thing on our agenda is there are some other information that Tony K would like to pass across. So Tony K, the floor is yours. Please go ahead. right, thank you very much. So, big shout out to everyone that came around. Big shout out to Chisom for honoring our call. So I'll give the honors to Juboy to help us with the conclusion and just round it up. So, Rojo, over to you.
All right, good evening, everyone. It was a very nice session from my own personal experience, and I'm very sure it's the same for everyone here as well. I mean, I want to appreciate Chisom for honoring our call. The questions were on point, and your answers were, equally brilliant. Thanks, Tony, for chiming in as well when you can. And Dominion, I mean, you were very, very, very brilliant with your introduction as well. So thank you for that too. Just like we've asked, please, if you've not followed us on our social media platforms, this is the right time to do so. This is where you can get, updates on what the Inventors is up to, our events in the future, and I mean, you can get to make good connections too as well. So I want to thank everyone present here today. I mean, this is not the last. I mean, there are going to be, events again in the future. And I don't know if in the future we can invite Chisom again. Anyway, I thoroughly enjoyed this session. Thank you. Thank you, everyone. If you have further questions, I mean, I assume that you can, drop it with either Tony or Lumide, and we can get them to Chisom even probably after this call. Yeah. Yeah, exactly. Yeah. Yeah, I mean, I think Happiness has already dropped some of the links, and I'm trying to look at my YouTube because I recently watched a video of Chisom maybe 2 days ago, a day in life. So I'll drop a link to the YouTube channel here again today, so now, so that I mean, if you've not subscribed, you subscribe to our YouTube channel immediately. So thanks everyone for coming. Just I mean, give me a second. So.
Thank you so much. Thanks. I really enjoyed the conversation.
Awesome. So we are trying to take a screenshot of everybody on this call. So everybody smile. Yeah, I don't pick up. All right.
Yeah. So I dropped the link already to Chisom's YouTube channel. So please do well to subscribe. And you get awesome content. Very sure of that. I mean, just take a look at the front page alone, the home page alone, and you're going to like it. So thank you everyone. Like I said, if you have further questions, you can forward them to me, Tony, Olumide, or even drop them on the Inventors Leads platform or Inventors platform rather. So we push them to try to get them to choose some to answer. Thank you, everyone. I don't know if there's anything Chisom would like to add or she'd like to share her thoughts. I mean, as we round up.
Oh no, nothing to add.
All right. Thank you. Thank you very much. Thank you, everyone. Enjoy the rest of your night and sleep well. Anything else? Bye, guys.